So, real quick, I got a bunch of stuff back from Emily this morning as I was walking out to class. So I'm going to send a progress report to you guys this afternoon with all the updated stuff that I've got in it, not including this obviously, but everything from last week will be in there, and I'll bring all those papers next class. You can just put it in the file. That's totally fine. No, you don't have to have it. Never do. So I'll get that back to you ASAP. I'll definitely get you a progress report out before the end of the day today, so you know what's going on from with the papers the grades I have, and that way when you get stuff back on Monday, you can collate it, make sure everything's copacetic. What else? How many quizzes? How many were there? Was there two? One was financial one, right? I think financial one, yeah. What was the other one?
Yeah.
Compounding interest, yeah, good, 3.6%. Oh, the logistic one from the UN. Good. How was that one? What was the carrying capacity? Let me do that one.
Yeah.
Fabulous.
That was easy.
It was easy.
Not too easy, but it was.
Well, good. I don't mind
Just
easy.
leave it. No,
I don't mind easy. I'm not changing. I was just curious what you guys thought about it. What's the carrying capacity of the Earth?
Is it?
I don't know. I didn't do it yet. I didn't run the data yet.
2024.
24 billion?
No, 15 billion.
15 billion?
2024.
Oh, in 2024 it's going to creep up to 15 billion. Gotcha. What was cool, I like that graph.
Approximately.
Oh, of course.
Yeah.
I thought it was 9.
That was 9 billion?
Yeah.
Oh, this
No,
is
it's 15.
I thought it was 9, so did the math teacher.
Can we go over that in class and see?
no, but I mean, I'll can't wait to see what you guys did. I can't wait to see what you guys did. So the idea is, it levels off at 0, then creeps up, and then does this, and that's the carrying capacity, is when it gets to about here, yeah. Interesting. I haven't calculated it myself yet, so I'll have to go back and look at it too. So anyway, again, exponential models are fun. Logistic models are a lot of times more appropriate because of the idea of the carrying capacity. I mean, I don't want to think about the Earth with twice as many people on it. I mean, honestly, that's what it would be, right? It's 15 billion, that's twice what we have right now. So imagine this room with twice as many people.
No,
That's kind of unfair. It wouldn't actually happen that way. Well, maybe it would, I don't know. Maybe it would happen that way. Anyway, I want to look back to a question that Trey asked last time that we didn't get a chance to answer because I'm an idiot. Because I pulled the stapler off the computer, hit exit, not save, and walked out of the room. And then Frankie's like, wait a minute, Trey asked a question about the coin flips. And I said, that's right, he did. So anyway, we're still in the middle of these coin flip averages. And I want to wrap those up today and get into cards, which is what you guys have in front of you right now as far as your little in-class quiz goes. This is that coin flip simulator that we had yesterday. And here are the results of the proportion of heads and tails currently up here, and then cumulatively over time. What I was supposed to do yesterday, and this is what, again, I forgot to share with you guys, was as you keep running the experiment, you'll notice that the current results fluctuate, sometimes wildly. Sometimes wildly. Oh, that was a 38 back there, wasn't there? So you get these crazy fluctuations, 40, 60, 40, 60, 46, 36, 61. But the point of it is, if I hold down the F9 button and I let this experiment go off to infinity, notice what has happened on the cumulative keeping track of chart. It's 50-50. When you talk about coins being 50-50, that is not a guarantee that every time you flip a coin twice, you're going to get heads and tails. It doesn't guarantee that. It guarantees that every time you flip a coin, you're going to get heads or tails on average every 2 times. It does not promise when they come. As you can see, looking up here at this block of 200 right now. 3 tails, a head, a tail, 4 heads, a tail, a head, a tail, 2 heads, tail, heads. I mean, if you look up in that plot of heads and tails, very rarely do you actually see just the heads and the tails. Very rarely do you see that. You much more often see runs. You much more often see runs of heads and tails, rather than, as a matter of fact, I've never seen heads, tails, heads, tails, heads, tails, heads, tails, heads, tails. And if I ever did, I think I'd pass out. But my pants. Because it shouldn't happen. It should not happen. There's basically a 0% chance of that happening. You guys showed some really cool randomness in the way you were, I heard you guys jokingly say when you walk in, head, tail, head. The way you generated those data yesterday on the board was pretty good. You showed pretty good randomness. You showed a nice number of tail runs and heads runs. I think there was even a 5 heads in a row at one point. But the point is, you can get fluctuation in the short term. In the short term, you can get fluctuation. Sometimes it's 50-50, sometimes it's 45-55, 42-58, 49-51, 54-46. But when you actually keep track over time, over and over and over and over again, you'll notice that the cumulative heads out to 50-50. Now this also goes for dice and cards and anything else. It's called regression to the mean. I think we jokingly talked about the Sports Illustrated paradox. I think we talked about that in class, yes? As soon as an athlete goes on the cover of Sports Illustrated, they start sucking the next week. We mentioned that, right?
Yeah.
It's called regression to the mean. Because very often, Sports Illustrated will go, oh my God, he's averaging 54% now heads instead of 50. Put him on the cover of Sports Illustrated. And the problem is that over time, he's going to regress back down because he was just at the high point and then he averages back to 50, as we've seen over here. So the SI paradox is just that they take an outlier data point and treat it like it's norm, when the norm is actually, well, normal. Hopefully that makes sense. Okay, good enough. So, Trey, I apologize for stopping this before we did yesterday, but you can see now that it's evening out to 50-50. You made a great comment about we should bet on tails, and that was because I had stopped it. Before I turned the screen off, I had stopped it, and tails was still ahead after a couple hundred trials. Yeah. What I should have done was, when class was over, put the screen back on, lifted the stapler, and said, now look. But I forgot to do that, so my apologies, sir. My apologies. But now you see the results. Now you see the results. Okay, what I want to get back into now is our data from yesterday. I want to start fusing statistics with our randomness.